We move straight on. We go to Radware and we welcome to the stage David Aviv.
I'm on top of the world. I'm on top of the world. Waiting on you for a while now. Waiting back into the room. I've been waiting for someone. Waiting for a while. Take me where I can. And the moon's halfway going down. So I'm ready to take the rock. Get up now. Get up. Get up now.
Very nice. Are you on top of the world?
Thank you.
Did you enjoy yourself last night?
Oh yeah, it's my first time at Risk. Very nice event. Surprise for the good, very nice. Enjoyable event.
Talked to a lot of people, made a lot of contacts.
Oh yeah. It's a wonderful event, especially after 3 years of
Yeah, absolutely.
being.
Happy being together.
Yeah.
I've got one word under your name, soccer. Football. Australia, New Zealand.
Yes, I like to travel, I like to see cultures, I like to meet people, to see different things, explore history, explore, simply to see something else, as far as possible, to enrich the limits, as we
But you
say.
follow sport as well.
Yes, I like
Do you play?
I used to. Well, you can see by the color of my hair, it's not anymore, but still active, jogging, doing sports, running, and from time to time when it comes, COVID put some stress on top of us, all of us. Anyway.
And you're ready to put some stress into your presentation?
Yes.
That's what you're really here for, and we're
Yes,
really looking forward to
Exactly.
what you've got to say for us. So I think we give you your full 30 minutes, because
Thank
nobody's
you.
hit the clock yet.
Thank you very much.
David Aviv, ladies and gentlemen.
Today we'll talk about a different technology, blockchain, but adapted to security, and many of you can ask what's the relationship between mining and signing blocks and security, etc. So hopefully after the 30 minutes we'll have a new idea the way we apply it with a new concept for application security. So a little bit about us, about Radware. Radware is an international company, and our focus business, you can see the suite of solution. Our business focus is on providing you application delivery controller, and primary security. It's network security, it's application security, it's cloud security. It's a full stack. We run our own cloud, worldwide cloud, for denied DDoS services, web application, API security, and bot management across the globe, with about 40 POPs, points of presence across the world, and we provide the customers security to the cloud, for the premise, etc. Last year, we spinned off 2 companies. One is the Skyhawk Security, and the spin-off is simply for accelerating the business value, accelerating the development, running as a startup mode, to be able to reach the market very fast, very effectively, but with the envelope of Radware. So one is the Skyhawk Security. It's for protecting your assets in the cloud, in the public cloud, AWS, Azure, very soon GCP as well. And the second one is Agile. Agile is based for service providers for network protection, for distributed, decentralized edge for service providers in the era of 5G. So we're taking both the 5G, the public cloud, and we accelerate the solutions. Together with our mainstream of solutions that you will see today, we hope to provide and cover a full suite of security solutions. Okay, so with that, let's go to our main goal of today, primarily application security. So, what I'm going to talk today is not on your enterprise network. You can protect your enterprise network. There are many solutions. Yesterday was a day full of that. I'm going to talk on the publicly exposed web and API surfaces that you expose to the internet or externally to anyone. So when we talk on those one, there will be three key elements that I would like to explain, and the changes that evolve in the market. Attacks are morphing all the time. I think the previous talk, you can see some of the morphing attacks that come in the pipeline, in the chain, the open source software, all the third parties, welcome to the world. Everything is binded with open source software, Log4j, everyone knows about it. You know, this is an extreme and extremely hard potato. So everyone has B2B dependencies with B2B APIs that you need to exchange data and you get and you are exposed to that. So from one side, you have the attacking morphing. Other side, your applications. Your application factory changing every day, maybe every hour, you know, depending on the pace that you expose APIs, you create your DevOps team, and the application developers create new endpoints, API endpoints, once a day, once a week, once 2 weeks. So you have both the application surfaces changing, the attacks are changing, and gentlemen, ladies and gentlemen, the adversary obviously knows it. They know by book, by the other very smart people. If we use AI, they use AI as well. They use swarm technology and AI power on the swarm in order to discover vulnerabilities, etc. So, community, we, you, everyone try to do three things. First of all, being able to automate what is called the incident response loop. I think yesterday you saw many examples of automating the incident response tool and many tools that can be used. And you know, the incident can start from the shift left or shift left side to the shift right to the runtime, etc. There's no limit. I mean, everyone will do it the way they would like to put it. Other side of the application, in order to go over and bridge the fact that you ever-changing APIs, you need to constantly discover the APIs in order to be able to do discovery, in order to adjust and adapt the protection policy for those APIs that are changing. And the adversary model, what we would like to do the most, address two key issues: identity and trust. Now, when I say identity and trust, everyone is connecting it to the enterprise network. Because in the enterprise network, you can establish identity, you can establish trust, zero trust, ZTNA networks, etc. There's a lot of solutions to address that. But when you run with anonymous users, browsers, APIs, machines that may come to the publicly exposed surface, there's no way, there's no agent, there's no any way to attach identity or create identity. There are some ways that we're doing. And that's exactly where the blockchain technology will come, and I'll explain later. So, when we look at the spectrum of what the adversary wants to do, it's intent-based. Based on the intention, they will either flood you, inject you, evade you, will scrape you, account takeover, based on the motivation, with a broad spectrum of tools, etc. So let's concentrate on the adversary. And the focus, what I would like to focus today, is about the trust identity from publicly exposed web and APIs. So, public application surface. Widely open, any anonymous, any external can access it. The defense practices, as of today, use different identities for this one. IPs, mostly fingerprinting technology. Correct? If you run anti-bot, you will have a fingerprint technology. And that's done for baselining, for tracking, and by that, being able to do incrimination of that identity, of that endpoint. Adversaries know very well. So what they do, they simply rotate the identities and change them. Give you an example. If I'm coming from a specific IP, I simply move to another proxy, another coffee. I'm getting the IP of the Wi-Fi network. Suddenly, if you baseline me based on that, I'm coming as a new entity. There's no way to trace you, to follow you, to apply the baselining that you have done previously and apply it on that. They manipulate errors. Many things. And the idea is simply to hide, bypass the entire defenses. So it's a cat and mouse race between the two sides. Looking at that, if we'd like simply to put a technical context on that, you can see the application factory behind me, the CI/CD and the publicly exposed APIs that are running. You can see the different models of the adversary and that are utilizing the trustless identities, the trustless either B2C or B2B, business-to-business machines or entity, could be consumer, anyone that would like to go and run a campaign against you. So, as we said, adversary will rotate identities, will manipulate others, will utilize public proxies like CDNs to change, to come, to hide identities, to cover themselves, and also erase traceability, which means from time to time the more advantaged one will simply flash their PCs. So any sign of you tracking, any identifier, any cookie that you have installed in is erased. Hello, I'm coming to you as a new person. There's no way for you to come and track me once again. So everyone is running runtime protection. Runtime protection, usually we have 4 different protections for those, the publicly exposed applications. Is the application DDoS, the application flats, the web application firewall, the API security, and the bot, the anti-bot protection. But we want to find a new way to establish, that's the problem. How do we establish trust for trustless entities? That's the main problem, because if we can solve that problem, then we can enrich the entire suite of those 4 solutions and be able to be much more effective to block and even prevent attacks. So remember, when we talk on those solutions, we talked on defensive and offensive. You will see the way we can use it also for offensive, as an offensive security, not only defensive. So that's the biggest problem, how to establish that trust. So we were looking on a new approach, a completely new approach to solve it. And we came up with a new way. What if we could play a game? Think of game theory. Trust as a game. So I'm the protected object. Everyone tries to come to me. I need to check each and every one. So I invite you when you are trying to connect to a game. In that game, you need to prove me that you are you without me knowing anything about you. Remember blockchain? Everyone that runs in a blockchain has a fear, digital identity, and no one is anonymous behind. Nobody knows who is it. Simply traceable with an unfakeable identity. So whenever I will be able to do that, on top of it, well, I can apply any analytics, machine learning, heuristic on that identity, and I can trace you. By tracing you, we'll be able to understand what's going on. So, think of a game. In that game, you need trust coin. You need a coin. Like you go to the casino, you play, you need the coin, you need to exchange coins. The coins are called trust coins. The game rewards those who play according to the game, which means I reward you. If I see that you play okay, and then I will let you more as a VIP. While if I see that you are trying to cheat with the cheat house, well, I will apply aggressive methods until I put you out of the game. Interesting. So it rewards the good ones and punishes the bad ones. Well, isn't that what we wanted? If I expose an API, an application, I run it, I'd like to be able to identify and classify the good, the bad, punish the bad, and let in the good. That's exactly what is the solution. So, how is that game translated into blockchain? The game runs 3 rules. That's it. The first one, be a member. You need to be a member, which means now you are a browser. You are API endpoint, external. I don't know anything about you. You need to prove me something. Be a member. So by being a member, you solve a challenge. The challenge is a hash. So you know it's some kind of a mathematical expression called an hash used in blockchain. So everyone that runs in blockchain runs and solves what we call proof of work. Okay? It was the third generation of blockchain. I'm not going into the blockchain technology. It's used for you to bring the proof of work and then run a consensus. And once you're in the consensus, you can sign the block. We are not signing any block because we are not in the Bitcoin business. We're in the security business. So we sign, once you prove, we do other things with you. So once you use, you create what is called a virtual identity or a crypto print. So remember, we used to have fingerprints. Now we have a crypto print. Being able to have a crypto print makes you a proof. The proof is not exposed. I mean, the secret remains inside your PC. It's non-fakeable. You don't expose it. You simply expose the proof of having it. Think of PKI. Simply by showing, like, say, publicly, say, well, I've done the handshake, I'm legal, I'm kosher there, I can continue and start again. So what we are members, start to pay to play. Which means, okay, you came to the casino, bring your money, I'll translate it to trust coins. I'm translating you to trust coins. You're getting trust coins, A trust coin, basically, and a proof of work, it's simply, you use CPU cycles to run the hash, and you play, and you start to play. Every coin gives you, let's for example, access for 10,000 transactions, let's say. So the amount of coins will determine how many transactions you can run against the open API and web applications. Once you consume or you deplete, the balance is going down to zero. You ask once again, give me coins, which means the system will provide you another proof of work. Solve it. Once the computer, the PC solves it, the endpoint solves it, it gets another one, another credit. Guess what? The exchange of coins will be based upon your behavior. Because what we are doing, we are running in parallel. When you start running your transaction, what we call continuous adaptive risk and threat assessment. Gardner calls it CARTA algorithms. On top of it, he will baseline understand your behavior. So if a good player, the contract of the application will apply you some number of coins and let you in. If you are starting to pay late, comes rule number 3. I will punish you. So I'm punishing the misbehaving one. What do we mean? Well, I will change the complexity of the challenge. So if before you needed an amount of CPU and memory resources to run the challenge, I will deplete, I will drain your CPU resources up to a point that I can even choke it completely. So suddenly, if you play the game, you have a way to control exactly the amount of transactions running in, baseline them, understand, and punish in various ways. So, it means that the trust level that we establish will provide you, will determine your admission. The way you do suddenly dynamic admission control. And that dynamic admission control will be based upon your, the way you behave. So you do a membership, summarizing everything. You do a membership, you get that identity. That identity is not fakeable. It belongs only to you. Once you did the membership, then you are getting more and more coins, you start to play. Remember that the coins are always attached to your identity, only to your identity. The ledger is having the ledger in the concept of a blockchain where you apply all the identity, you keep the database, the identity, and you keep the state of each player. So at any point of time, the status of each player will be recorded at the ledger itself, and once again, you are gaining trust and reward, and as we said, you run it, and you run on top of it CARTA algorithms, continuous adaptive risk and threat assessment. So, once we have established the idea that you can now control anyone that comes to your open environment, create an identity, baselining, and now even provide controlled admission control. Let's see the way we are taking it to the next level. So, obviously, this is a tool, an excellent tool for prevention. Because the more and more we understand, faster I can prevent attacks by, let's say, I can do different kinds of mitigations. So the next slide, I will take you a little bit deeper into technology details, not that much, because I know it's a technology session. So let's look how we do it. It's a real-time implementation. That's the way it runs. It runs to the end customers. So you have applications exposed at the right-hand side, the good guys. You expose, you have a public edge. The enterprise as a public edge is exposes, it's the domain, and you have the browser or APIs, the trustless machines. So you can see here, the way it's implemented, run a control plane. The control plane can run at any cloud at your premise, and the cloud doesn't matter. It's a control plane that you maintain as a security organization. The control plane will contain a ledger, that kind of centralized ledger, and the logic, the application logic, and we utilize the control plane. Everything is done by downloading a JavaScript or an SDK, simply the simplest way to communicate with the browser. JavaScript will contain an electronic wallet. The e-wallet is getting you coins. It's creating the identity. You can feed the identity as a micro miner. So the idea is that every one of you that are running now a browser running towards the protected application is getting a micro miner running in the JavaScript. That's it, controlling the JavaScript. The micro miner needs to mine in order to get coins. And the way to mine and control, get the coins will be according to the behavior of that end machine, of the user, who is controlling it. So once you do it, you can see that you start a membership, non-interactive, on the control plane only. You work to get to be a member. Once you're a member, you are starting through the control plane, start to play, namely, I'm a member, I created my CryptoPrint, I'm getting my coins to play the game. Now, I can play the game. So every transaction that runs towards the protected object is signed by the browser, simply signed. Having the proof, hey, I've enrolled, this is my identity, and I'm playing now. Now, being that, we starts the game. At the game time, we will collect identity vector and activity vectors. And the reason for that now, the security controls and logic will run the behavioral machine learning, what we call the continuous adaptive risk and threat assessment, simply to assess and understand, hey, what are your spending patterns? The way you spend shows exactly the way you play. If you are a legitimate player, you will drain very fast the coin. If you don't drain the coin very fast, you play according to the rules, well, it's much better. We'll try to assess if you are changing identities. Maybe you are rotating fingerprints, or try to change the CryptoPrint. So we understand both the behavior. If you're trying to change the identity, what is the tracking, the activities that you do? Okay. So, based on that, we profile you. We profile that CryptoPrint, and we provide the intent, and we provide a trust code. So, one way, so once now that we establish both the trust code, the identity, we can start apply mitigation or punishment if needed. So one way to do it is the old ways, the defensive. Run it in the reverse proxy. So over there, I can simply shut down the session at a reverse proxy. You can use any reverse proxy that you have. That's the common practice. The new practice is simply activate the micro miner at the browser. providing a much stronger challenge. Now the challenge will start draining the CPU and memory resources before solving the hash, so it cannot communicate outside until it solves that hash. Or even choke it down, depending on the aggressiveness of the policy that you would like to apply. This is the outcome. The outcome of the game is balancing the risk that I think that your attacker and the miner cost, the micro miner cost, the activity. If you are a legitimate one, you will have an initial admission cost, and then the price will be meaningless because you play the right way. For the defender, this is the price, it's linear. I mean, you have no resources, etc., no reverse properties, it's like a linear price. Primary price is the attacker. So once you do that, basically you push the attack, you push it to the attacker, to the attacker's surface. The more we will make the risk that he imposes to us is higher, you can see that the micro miner cost will be higher. He will drain more and more his resources. By the end of the day, think of it all. Simply bounces the edge, your enterprise public edge will bounce off all the high risk endpoints, devices, users, automatically. Will inflict the cost of the attack on the attacker rather on you. And that's the point. Because by the end of the day, the business value is how much money you need to invest in order simply to... Let's assume that you have already mitigated it. It costs a lot of money either to mitigate. So why not to push part of the attack, the cost on the attacker itself? And that's the idea here. The way you can deploy it, you can deploy it across any edge that you run. You can run edge anywhere. You can run an edge by the end of the day at CloudFront. It's a reverse proxy. So any of the clouds, Kubernetes, it's not, the nice thing about it, your public edge is not restricted by this architecture to any service architecture or edge architecture that you have deployed. You can run it in any cloud, virtual, thank you, Kubernetes, and you can run it in your premise. So, to summarize, common practice today to identify you today is done through capture. And you know the capture very well, annoying, etc. Most important, it's binary. Once you solve it, that's it. You get a grace period. By that time, you can do anything you would like, until I catch you once again. This one is a captureless approach. Using blockchain paradigm, actually Ethereum, we use the Ethereum platform, the concept, the principles, and by that, it's completely non-interactive. Don't need to do anything. It runs in the background, in the control plane that the micro miner establishes with the backend, with the application edge, and it is continuously monitoring. There is no grace period for you. We are actively monitoring all the time in order to determine who you are, what you are, and the most important, the identity, the cryptoprint is non-fakeable. No way you can try to rotate it. You will see it's extremely hard to rotate it, or anyhow, if you try to rotate it, there will be a sign that you try to rotate it, and most important, it will imply that you are one of the bad guys. With that, thank you very much.